Yeah, this is a problem you don't need to use the formulation from the back side of the book. Okay. So here's a integral of x times sine x cosine x. Okay. Remember, we are able to do the problems on x sine x dx, right? X cosine dx, right? And those, we did some problems of that before. Use integration by parts. We don't like the x in front of sine x or cosine x. What you should do is to differentiate x, so you get rid of x. We use the integration by parts. But now you have sine x, cosine x. We have a trouble, right? Now you can, yeah. So you have to do something. This is a very special function. So we still use similar ideas to evaluate this integral to get rid of x using integration of parts. Before we do that, we have to modify the function. And a typical formula is whenever you see sine x, cosine x, you know this is going to be sine 2x, but you have to divide by 2, okay? Yeah, so you combine into 1. Then you can use integration by part, okay? So this will be dv. So what is v? V should be equal, u is going to be x, right? V should be equal to cosine 2x. There's a negative sign there, and divide by 2. Okay? When you differentiate, you get sine 2x. Okay? So let's do it. And so it's be uv minus v du. Okay, du is just dx. Negative x cosine 2x. Here's negative, and there's a plus, actually, the negative sign, right? 1/2 cosine 2x dx. All right? So let's multiply this out. X over 4 cosine 2x plus 1/4 integral of sine cosine 2x. The entire derivative will be sine 2x divided by 2, and the plus constant. So this will be the answer. Okay. So the idea is to modify the function a little bit, so you still get a similar type of integral like x times sine x or x times cosine x. This is a yeah, with the integration by parts. Okay. So our next problem, integrate. Let's continue using integration by parts. There are many problems you can use integration by parts, but not always. You know, you have to use integration by parts. Okay. Like this problem, natural log of 1 plus x squared dx. Okay. 1 plus x squared is inside natural log. And I will record the ideas natural log of x dx, right? That's what we did before. We use integration by parts. Okay. But here I have 1 plus x squared. We don't have any choice. We have to stay with the integral parts. Just go ahead and do the right. Now you can use a substitution. You can let the 1 plus x squared, 1 plus x squared equals u. Then I think I have a trouble to simplify it. So let's use the integral part, because this will be u, that will be dv. So v is x. Okay. So you get uv minus v du. Okay. uv is v is x. V is x. U is the natural log. Okay, minus x. Yeah. Now the derivative u with respect to x is a chain rule. It's going to be 1 plus x squared and twice of x dx. Well, at least I can get rid. At least I get rid of natural log, right? In the integral. But create a complicated functions. Okay. So I put 2 here, I get x squared 1 plus x squared. But this is a rational function. Okay, this is a rational function. So what they should do? Well, x squared divided by 1 plus x squared. You can decompose it. Okay? And x squared 1 plus x squared is going to be x squared plus 1 minus 1, 1 plus x squared, which is going to be 1 minus 1 plus x squared, right? So that's it. Yeah. You can use a long division to get that. Okay? Then we are almost done. So this is called two-step problem. Yeah, we're not going to go further. That's two-step problem. So here's the integral 1 minus 1 plus x squared dx. All right. So the integral of the first term is x. The integral second term is a standard formula there. Here's x. The integral 1 plus 1 of x squared. This is arctangent x. Okay, it's plus. Okay, so we know some formulas. Let's recall some formulas. Like 1 plus x squared dx is going to be arctangent x plus c. But how about 1 plus x squared dx, right? And that is going to be, do you remember that? Yeah. Hyperbolic, inverse hyperbolic sine x, I think. And we do have to memorize those integrals, the derivatives of inverse function, inverse of sine x, inverse of cosine x, inverse of sine x, inverse of tan x, and inverse of hyperbolic sine x, inverse of hyperbolic tan x. Okay. So this is yeah. So those formulas are not given on the quizzes. Okay. So let's do next problem. This is a pretty strange equation, right? Integral. So can you try this? Any idea? Well, we probably have to use a substitution to simplify it. Okay, what kind of substitution you're going to use, right? We don't like natural log inside the square, right? So it's a very natural idea trying this substitution. It allows u to be natural log of x. So du equals 1 of x dx. Not too bad. So this is going to be just one substitution. That's the end of the story. Okay, dx over dx, just du. And once you get this, you should know what is the answer. Okay, the formula is over there, right? So it's going to be hyperbolic, the inverse hyperbolic sum u plus. Okay, so yeah, and that is u is going to be natural log of x and plus constant. So just couple lines. That's called the one. Yeah, we call it one-step problem. You just need a one idea substitution. Okay, sometimes the substitution combined with the integration by part, or sometimes use the two substitutions to solve the problem. Okay. Yeah. like this one. I changed the problem a little bit. Okay, please do it. Right. The only difference is on the numerator, I put the natural log of x. Okay, so please work on this problem. Right, so use the same substitution. Right, no other choice. So du equals 1 over x dx. Then the integral becomes, and there is just addition u there. Dx over x is still du. Now, when you see an integral like that, we call it two-step problem. You need two ideas, right? You need another substitution. You need another substitution, which is 1 plus u squared. Okay, so you let w to be 1 plus u squared, and dw equals 2u du. Okay, so the integral becomes square of w. U times dw, it's a 1/2 of dw, right? So this is going to be integral like that. This is integral power function. Then you know how to do that, right? It's going to be 1/2 1 minus 1/2 omega 1 minus 1/2 plus constant. Okay, let's simplify it. It's going to be just like that. Okay, so you back to w u, right? So 1 plus u squared to the 1/2. Then you continue. What is u squared? U squared is going to be u is going to be natural log of x, and this 1/2 plus constant. Okay, so that's our answer. Yeah, we call them a two-step problems. Right. The next one I want to discuss. It's also just need the one substitution, but I have to be careful to the substitution. We did a similar problem last time already. It's a sine to the 5th x, cosine square x dx. Right. The good part is we have the other power, right? 5th. So sine to the 5th. The standard method is going to be sine to the 4th x, cosine square x, and sine x dx. So you can use substitution. Just substitution for this problem. Okay. So this part, I want to get something like a du, right? It's not integrated per part. So you let u to be cosine x. Then du equals negative sine x dx, right? That's good. Okay, then the rest of them we have to express in terms of cosine x. Okay, that's okay because sine to the 4th power is going to be sine square, right? And sine squared is 1 minus cosine squared. Okay, so it's going to be, yes, the rest of them can be expressed in terms of cosine x. U is a cosine x, so it's going to be integral of 1 minus u square, u square, and then negative u. Then that's a polynomial, clear, right? It's polynomial. So you know how to evaluate the integral polynomial. So you have to expand it. It's u minus 2u squared plus u to the fourth power u squared negative u. Then multiply this out. I put a negative sign inside. I will get negative u squared plus 2u to the fourth power minus u to the 16. Right? And this is a polynomial, not very complicated. And then you find the entire derivative of each term. And plus constant. Now what is u? U is a cosine x. So you put the cosine x back. So this is a type of problem. This is a little bit longer, right? Because but the idea is very simple, just one single substitution. Okay. One single substitution. All right. Next. Let's look at this problem. X squared minus 1 over x dx. It's not like if I turn this upside down, then probably it's easier to solve it. Now this is quite different than this problem. Okay. That problem on the right hand side is much simpler. Just use a substitution, standard substitution. Okay, the problem on the left, it's much more complicated. Can you use a substitution let x squared minus 1 to be u, right? Then I don't think you can do that. Okay, it's possible. You know, you try different ways to do, right? Substitution. Then they tried, let's see it, and it's not working, then we start new method, right? So this is standard substitution, well-known standard substitution, right? So du equals 2x dx. But then I do have it's going to be square of u, right? I have x here. And what is dx? Dx is going to be 2x du, right? Then you end up what? You end up with 1/2 square of u. Then you have u squared. U squared, x squared. X squared is going to be u plus 1. Okay? Now what? It's simpler. Let's leave it simpler. But let's see u plus 1 here. Right? X squared is u plus 1. Then you have to continue your substitution. Maybe. Okay. Sometimes stick can get out, you know, you can find a way out. Okay. Okay. So then you can let u to be maybe w squared, something like that. Okay. So you can get rid of radical if you don't like the radical. Okay. So you can let w squared to be u. Okay. Let's try this, right? And then then this will be square of W, so it's W. U is the W square. And what is du? Du is 2W dW, right? Not too bad. We can get this. You know, this become a 2 or 3 step problem, like 2 substitution involved. Okay. Okay, so you get 2W square, W square plus 1. And remember, right, we can separate, it's going to be 1 minus, right? And that's what we did before, right? So you get integral of W minus, what is that? Arctangent W. Right, inverse of, inverse of tangent. So derivative of, the derivative of inverse of tangent x is going to be 1. Okay, so now you have to go back, right? We get rid of the integral symbol right now. So what is W? W is the square of U. And what is U? U is x squared minus 1. We do get an answer like that. Okay, it works out. We do use maybe 3 ideas, 2 substitutions plus the decomposing of 2 functions. So if you make a wrong choice, you either cannot finish the problem, or you have to go through very hard, several steps, finally get out. That finished, right? So this is true in mathematics, also true in the life, right? If you make the wrong choice, your life get much harder at the end. So you have to make a wise choice. Okay, similar, yeah. Right, so let's go back to the problem. I had this graduate student in our department, it's my student, and he got here and he met a girl and got married quickly. I told him, don't get married so in big hurry. He got married, the next year get divorced. I said, what's the point, So this is just like make the right choices, Yeah. Okay, so this is a integral, right? So we go back to this. What is the best choice? Right? Remember, we call it trigonometric substitutions, right? So how to make something square minus 1 become square, right? We know that secant square theta equals tangent square theta. Okay, so in the place of x should be secant theta. Secant square theta equals, right? So let's try this. So you let x to be secant theta. Maybe that works. Okay, then this integral here, x is a secant theta, and then on the top is going to be secant square theta minus 1. And what is dx? The derivative of secant theta is going to be tangent theta, secant theta, d theta, right? That's a dx. This is a dx. Okay, numerate is going to be tangent theta. Okay, the denominator, secant theta, here's tangent theta, here's secant theta, d theta. So secant theta is canceled out. I end up with integral of secant theta. Okay, it's not too bad. Secant square theta. But how can I integrate? Right? It's a sine square over cosine square. I remember the derivative of secant theta is going to be derivative tangent theta. Okay, sorry. Derivative tangent theta equals secant square theta. Okay, but I have sine tangent theta here. There's no direct antiderivative of tangent square theta. But integral of secant square theta, yes, it's going to be tangent theta. But to me, tangent square and secant square are almost the same, they're related, right? Just like sine and cosine. Okay, so it's here, right? So you change it to secant square theta minus 1. Then antiderivative secant square theta is going to be tangent theta and minus theta plus c, because second part is minus 1. So that is the antiderivative of the function. So next part, I have to express tangent theta in terms of x. I know x is secant square, right? So what is tangent theta? It still goes back to this, okay? And this is a secant inverse of x, because theta is going to be, x is going to be secant theta. So it's 1 minus x squared, and that is the answer. Or x squared, no, minus, wait a minute, x squared, yes, so that's my mistake. This is a secant square theta minus 1, so that's x squared minus 1. If I compare this answer with the above answer, the only difference here is a secant theta, arctangent theta, yeah, the inverse of secant x, right? So what I got above is this. So do I missing something? Yeah, there are some slight different expressions. But you can show that maybe they're equal. Right? They should be equal if my computation is correct. Okay. Yeah. Okay. Now, if we look at the back side of the book, this is a pretty standard integral. It's already listed, the answer. And you look at the back side of the book, it's the formula by number 41. Okay? It says that it's going to be square x minus 1 and the minus cosine inverse, cosine 1 of x. And they put absolute value there. Okay, plus constant. It should be the same. Okay. Why is this two are same? Okay, let's call it the y, right? Okay. That means secant y equals x, right? So that means 1 over cosine y equals x, right? That means cosine y equals 1 over x, right? That means y equals arc cosine 1 over x. Okay. Yeah. We probably have to put absolute value here, but yeah, that's some small difference. It's okay. We assume x is positive, yeah. Then you don't have any problems with that. You see that, right? So it's the same. So in other words, secant x is going to be arc cosine 1 of x for positive x, okay? Okay, so different way to solve problem and get different answers. So anyway, in the book, yeah, if you're allowed to use the textbook to evaluate integral, you just look at the backside if this or this in the simplest form, and then you may find the integral there listed, and just write an answer using the book. But many problems you have to use a substitution to simplify to the standpoint. Right? For example, like integral of x squared square root 9 minus 4x squared dx. First thing you have to do is to use a substitution to simplify. It's square root 9 minus 4x squared. I want to write it as 1 minus u squared. So the substitution you can choose is, look at the 9 minus 4x squared. I take a 4 out, right? I get 9 over 4 minus x squared. So I think my x should be equal to 3 over 2u. Right. Then you square it, then you get 9 over 4. You can take it out. So this is the idea. Okay. So that's a substitution. You will get square root 9 minus 4. And you define x squared is going to be 3 over 2u squared. And then 3 over 2u squared. And dx is 3 over 2 du. Okay. So let's simplify. You will get, here's 9 minus 9u squared. Then here's 9 over 4u squared. Here's 3 over 2 du. So you will get 3 out of the radical. The 3 cancelled out. I think you take a 9 out here. I think 4, 2 can be taken out, 8. And that will be u squared, 1 minus u squared du. Okay. Double check, yes. Okay, that's correct. All right, then you get, this is simplest form. Then you can look at the back side of the book. You can stop here after you simplify. Then you look at the back side of the book and see any similar integral there. And you find the one, which is number 34. Right? So you get by number 34. Okay, it's on the back side of the book. Then this will be negative 1/2 of u, 1 minus u squared, plus half of arc sine u, plus constant. Right? Then you go back to put u, replace u by x, because u is going to be, u is going to be 2 over 3x. So you can put back 2 over 3x, 2 over 3x squared, plus half of sine 2 over 3x, plus constant. Right. And simplify a little bit. I think the first term will be 3 over 8, 1 minus 4 over 9x squared, and multiply this out, and 9 over 16, arc sine 2 over 3x, plus constant. It's pretty complicated, but you can stop there using the integral. Right? If I put the problem on the quiz, I will give you the formula for the it's from number 34. Yeah, formula. I gave you the number 34. So all you have to do is find a way to simplify the integral to the standard form. Now, can you evaluate this integral? The answer is maybe yes. Okay, if I ask you to evaluate this integral, okay, what you should do? You have to use trigonometric substitution. Okay, technically you can do that, but then this problem becomes like a 4-step problem. It's too long. Okay, we usually try to give you a problem maximum is 2 steps, two ideas. You have to use 2 ideas. Okay, so but if you're given a problem like that on the test without the giving formula, then you have to find it by yourself. Okay, so the standard idea here is you use substitution. Let's u to be sine theta. Okay, the trigonometry, right? Then 1 minus u squared is 1 minus sine square theta, which is cosine square theta. Then you can get rid of square root. All right, so let's do it. It's integral, not too bad, right? It's going to be 1 minus sine square theta, and here sine square theta, and then du equals cosine theta d theta. It's not too bad, yeah. Just a couple more steps. Okay. Then the denominator is going to be cosine theta. Numerator is it. And cancel it out, then the integral of sine square theta is pretty standard. Everybody knows that, right? So it's going to be integral of sine square theta. It's going to be 1 minus cosine 2 theta divided by 2. Then you have an anti-derivative. Yeah, anti-derivative. The first one is half of theta minus sine 2 theta divided by 2. Right? Then that's not that. Yeah, you have to change it back to u. Sine theta. All right. So sine theta is going to be sine 2 theta cosine theta. So it's get sine theta cosine theta plus constant divided by 2 to cancel out. So sine theta is u, cosine theta is square root 1 minus u squared. So my answer here is going to be x sine u, right? Minus u. That's the square root of 1 minus u squared, the constant, okay? Plus constant. This is a cosine theta. This is sine theta, okay? This is the theta. Did we get the same answer? That's listed in the book. Yes. Okay. It is exactly the same answer. But we solve it by ourselves here. So it's possible a problem like that to be on the test. Okay. We ask you to use a trigonometric substitution to solve the problem. So there's so many different types of problems here, right? With all kinds. Sometimes we do need a formula, simple formula. So you have to memorize the formulas for the derivative of the arctangent, arcsine, hyperbolic, the inverse hyperbolic sine, the inverse hyperbolic cosine, tangent. Okay. And so there are few formulas we do need to know. Okay. is x cubed 4x squared minus x to the 4 dx. Right, before we solve the problem, okay. Let's think about the possible ways to solve it. You can eventually solve it using all the methods you learned. Okay. But I want to try to use a formula in the backside of the book. So let's simplify to a certain level. Okay. So x 4x squared minus x to the 4th. It's negative x to the 4th minus 4x squared. Okay. So I got negative x square minus 2 square. I think it's plus 4 minus 4, so it's minus 4. Okay. So that means the integral is going to be equal to this. Okay. So it's 4 minus x squared minus 2 squared dx. Looks much better. Then I have to use substitution. I allow the w to be x squared minus 2. Okay. What I get is dw equals 2x dx. Okay. That's fine. So I have an x cubed. So x cubed is x squared times x, right? So x cubed is x squared, 4 minus x squared minus 2 squared and x dx, right? So let's replace it. X squared is w plus 2, 4 minus w squared, and half of dw. Okay. Right? We end up with two integrals. Right? We end up with two integrals. The first integral is this. The second integral is just integral 4 minus w squared dw. This is a typical integral. You can use a trigonometric substitution. The first one uses a standard substitution. So without using any formula from the book, you still can solve the problem. Okay. First, you use a completed square and it's right choice, of substitution. You end up with the two integrals. For each integral, you need to find the right substitution. Yeah. So we can give you two different problems on the test. The first one, let's do that, right? The first one is, and we come back to this, right? Just evaluate this integral, right? How do you do that? Just simple substitution. Okay, so let y to be 4 minus x squared. Then dy equals negative 2x w, okay? Negative 2w dw. Okay. Right, so the integral becomes square root of y, w times dw is going to be negative 1/2 dy, okay? That's that. That's just one step problem, right? And here y to the 1/2 dw, dy, okay? So the entire derivative is going to be, oops. So antiderivative of this is going to be, oh, it's gone. So here, that's a y, square y, right? And that's going to be, this is a dw. So it's going to be -1/2. Okay, well, this is a problem. Where's my file? Oh, yeah. Did I touch the button? Okay. No. Okay. So that would be -1/2. The computer is unstable right now. Okay. Something's wrong with it. Let's try one more time. Okay. Oh, wait, what's going on? I'm forced to leave the meeting. No. Okay. All right, so use a substitution, the standard substitution, then you will get -1/2 dy. All right, so what this time right now? I'm not gonna record this. This is a weird. Okay, so what I'm gonna do is I close this. Give me 1 minute.